Okay, guys, this is section 15.1, video 1, and 15.1 section is, 15.1 section is introduction to rational expressions. Okay, so first, rational expressions, again, they are similar to rational numbers. So let me talk first about rational numbers. That's any numbers which can be represented as a ratio. So technically, rational numbers are ratios of two integers. So example, 1/2, -3/7, or just 5. 5, it's also a rational number because 5 can be the same as 25/5. Okay, so that's rational numbers. However, we focus on, in this section, on rational expressions. Okay, so rational expressions are the ratio of two polynomials. So let me, and again, usually they have a form P over Q, such that Q can be equal 0, okay? And P, Q are polynomial. They can be expression, but I'm just going to put it are polynomials. So let me give you the example of rational expressions. Again, 2x, for example, you have 2x minus 5 over x to the third power minus 2. So this is rational expression. You see ratio, which means fractions of two expressions, of two polynomials. Numerator, it's polynomial of degree 1 because the power of x is raised to the power of 1. Denominator, it's a polynomial of degree 3 because power of x is raised to the third power. So that's one of them. Rational expression, again, it can be also ratio of two integers. Let's say 5/7, because if you don't see the variable, the degree of polynomial, it's equal to 0. But that still is rational expression. Or you can see something with higher degree, like 6x to the power of 7 plus 2x squared over 4x cubed. Okay, so that's some of the examples. So what we're going to do in this section, there's three major things. You're going to learn how to evaluate rational expressions, how to find the restricted values, and how to simplify rational expressions. So there are three major objectives. I'm going to start with the first one. First, we're going to talk about evaluating rational expressions. Okay, so that's our first major objective here. So evaluating means replacing x with a given number, and that's what we're going to do here. So let me give you example 1. For the given value of x, evaluate the rational expression And our rational expression has form x minus 3 over x plus 5. And let's do 3 examples. A. Evaluate this rational expression when x is equal to. So what we're going to do, we're just going to plug it in. We're going to substitute x with 2. And simplify. So we have 2 minus 3 over 2 plus 5. We're getting negative 1 over 7. Okay, that's it. We evaluate. B, evaluate the rational expression when x is equal to 0. So the same thing, we're going to substitute x with 0. So we're having 0 minus 3 over 0 plus 5. We're getting negative 3 over 5. And C, evaluate when x is equal to negative 5. So we replace x with negative 5. So we're having negative 5 minus 3 over negative 5 plus 5. And we're getting negative 8 over 0, which we know this is undefined. We can't divide by 0. So what happened here? So what happened when x is equal negative 5? When x is equal negative 5, we can't evaluate the rational expression. So the value negative 5 is called the restricted value of rational expression. So the restricted value of rational expression, it's the value which make our rational expression undefined. Okay, there's no way that we can simplify, we can evaluate our rational expression when x is equal to negative 5, because when then we divide by 0. This is something what is undefined. Just pause for a second. Resume. Okay. So x equal negative 5, it's called the restricted value of rational expression. So let me give, since we talk about this, let me give you the definition, the nice definition of the restricted values of a rational expression. So the restricted value of rational expressions are all values. Again, it can be 1, it can be 2 or more, that make the rational expression undefined. What means make expression undefined? That is make the denominator equal to 0. Okay. 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 So let's go back. Now, this is important to find all restricted values set up the denominator, set up the denominator equal to 0 and solve the resulting equation. Okay, so I'm going to pause. I'm actually recording this when you guys taking a test. So we'll get back. Okay, so let's do examples. Identify the restricted values. Okay, so we're going to do a couple examples. You have a plus 2 over 2a minus 8, and you have to find the restricted value. So what you're going to do, you're going to take your denominator, which is 2a minus 8, and you're going to make that equal 0. And now what you're going to do, you're going to just solve for a. So we're adding 8 to both sides, and you're getting 2a equal 8 divided by 2. We're getting a equal 4. So a equal 4 is the restricted value. Okay, so what that happened when a is equal 4, the denominator of this rational expression will become 0. So that means the rational expression won't make sense. Okay, more emails. So let me pause that again. Okay, and let's do a little more to find the restricted values. Let's do b. W minus 4 over w squared minus 9. So take denominator and make it equal 0. So that will be that w squared is equal 9. I'm adding 9 to both sides. And to solve for w, you're taking the square root. That will give you that w is equal 3 and w is equal negative 3. So we have two restricted values. Or I want to review that you could also factor w squared minus 9, because this is the same as w squared minus 3 to the second power, which you can factor as w minus 3 times w plus 3. And then you make your denominator equal 0, and you're solving two equations. W minus 3 equals 0, w plus 3 equals 0. And we're getting w equal 3, w equal negative 3. Okay, so that's another way to solve this quadratic equation. Okay, and I just want to do one more example because this example is a little different. So see, we have to find restricted value, and we have 8 over z to the power of 4 plus 1. So the idea is the same. You take the denominator and you make a 0, and you're trying to solve for z. So if you isolate z on the left side, you end up with z to the power of 4 is equal to negative 1. And then to solve for z, you should take the root of index 4 from both sides. Okay, so we're getting z is equal. Now, root of index 4 works like square root. Okay, all the time when the index of root is even, those roots behave like square roots. So what that means, this is undefined. Think about the square root of negative 1. We cannot find the number, which by multiplication will give you negative 1. Here we have root of index 4 of -1, there's no way that we can find that solution because there's no number which by multiplication multiplied by itself 4 times will give you -1. So again, that can be solved. So what that means, okay? That means that we don't have restricted value. That means there is no value which will make this denominator equal 0. That's it. That's what is the meaning of that. Okay. So again, like you guys see, I'm pausing and resuming a lot because you are at this moment taking a test, and I'm trying to respond to your messages. Okay, but it looks like so far everybody's good. So let's continue. So in this example, we don't have restricted value. If you can't solve the equation, that means, or you cannot find those values, it should be fine. Okay, another email. Okay. Okay, have to pause again and respond to your emails. Not a good timing to record the lecture. Okay. Okay, let's continue. So we don't have restricted value. Okay, next what we're going to do. Next objective of this lesson is about simplifying rational expressions. Okay, and I'm going to explain all the steps based on this example. Example, given 5z plus 25 over z squared plus 3z minus 10, simplify the rational expression. Then find all restricted value. So first what we're going to focus on simplifying rational expression, and I'm going to write down the steps for you. So to simplify rational expression, what you need to do first. So step 1, you need to factor the numerator. Okay, so we need to rewrite numerator in factored form. So in our example, numerator, it's 5z plus 25. You definitely can factor GCF. GCF is equal 5. So we're factoring 5, and we end up with z plus 5. Okay, so let's save that. Step 2, we're going to do the same thing to denominator. Factor the denominator. Okay, so denominator is z squared plus 3z minus 10. So this is our quadratic equation. So you guys learn how to factor those quadratic equations. Just factor using AC method. Okay, so let's review. A is equal 1, B is equal 3, C is equal -10. A times C is equal -10. We're going to find two integers which by multiplication will give you -10. and the same two integers by addition gives you b, which is 3. So what's going to work? 5 and -2. So this is easy case. Hope you guys remember that a is equal 1. So in this case, we're just going to create our two factors. We're going to put z in each parenthesis, plus first integer, which is 5, plus second integer, which is -2. So let's save that. This is what we got when we factor denominator. Now, what will be the step 3? Step 3 is rewrite the original rational expression using factors. Okay, so our original rational expression was 5z plus 25 over z squared plus 3z minus 10. Okay, so we factor numerator already, and we got 5 times z plus 3. So let's copy that. So this is the same as 5 times z plus 5. And we factor the denominator, and from denominator, we got z plus 5 times z minus 2. Okay, so what you're going to do next? Step 4. Just put that in orange. Step 4. Cancel the repeating factors or expressions, whatever that is. Okay, so in our case, what we're going to cancel, we have z plus 5 on the top and we have z plus 5 on the bottom. So this is the same factor. So we can simplify our expression. And after canceling, we end up with 5 over z minus 2. So this is the simplified form of the rational expression. Original rational expression. So I just want to explain it that 5 divided by z minus 2 is the same, it's equivalent to 5z plus 25 over z squared plus 3z minus 10. Okay, they both, if you will graph it, they both graph the same way. They the same expression, but we technically, again, you have rational expression, so like a fraction, you have a ratio, you reduce the fraction. That's what we're doing. So to be able to reduce the fraction or any expression, you need to have a product. Okay, so you have to have a multiplication, and that's what we're doing here. Okay, so we have this. Now I want to go back because on the next test, I will ask you simplify rational expression, and of course I'm going to ask you also to find all restricted values. So let's review that. Now next, to find all restricted values, and I want you to pay attention to that. Always work with the original rational expression. Okay, so original rational expression was 5z plus 25 over z squared plus 3z minus 10. So I just teach you that. So how are you going to find restricted values? You're going to take the denominator and make it equal 0. So you solve the equation, make the denominator equal to 0. So we have z squared plus 3z minus 10 equals 0. Of course, I don't want you to factor this again because we already factored that, okay? This is quadratic equation. So you guys learned that in previous section. So z squared plus 3z minus 10, again, to solve that, rewrite this using factors. So we factored that already with AC method, and we end up with z plus 5 times z minus 2 equals 0. And now you can use zero product rule, which means you're solving two equations, z plus 5 equals 0 and z minus 2 equals 0. So that will give you that z is equal negative 5 and z is equal 2. So we have two restricted values. Our restricted values. So just remember, because you're going to simplify rational expression, that's what we always do with them. And then when they will ask you to find the restricted values, which means the numbers, the values for which the denominator is equal 0, don't go to the simplified form, because look what happened. If you will go to simplified form, you will just solve that for make that equal 0, you'll end up with z equal 2. So you will only get half of the credit, okay? You will miss z equal negative 5. That's why you always going back to your original denominator and make that equal 0 and solve it, okay? Original, not the simplified one. Okay, so we did this one. So let's practice more. Let's do B. The same thing, simplify and find the restricted values. And in B, I'm giving you 2x minus 14 divide by x squared minus 49. So first, you're going to rewrite numerator using factors. So we need to factor numerator. GCF here, it's equal to, so this is the same as 2 times x minus 7. Okay, so let's save that. Okay, so this is step 1, factor numerator. Your step 2, factor denominator. So your denominator is x squared minus 49, which is the same as x squared minus 7 to a second power. And I hope that you guys remember the formula a squared minus b squared, which is the difference of squares formula. When you have a difference of squares, it's super easy to factor this. This is the same as a minus b times a plus b. A and b are the bases of exponents. So that will be x minus 7 times x plus 7. 1 second. Okay. So in our case, a was equal x, b was equal 7. So we have it, okay? This is the factored form of the denominator. So the next one, what we're going to do, we're going back to our original problem, and we rewrite numerator using the factors, which is the same as 2 times x minus 7. And we're going to rewrite the denominator using the factors, x minus 7 times x plus 7. And now we can cancel repeating binomial. X minus 7, it's on the top, x minus 7 is on the bottom, so that will cancel. So our solution will be 2 over x minus 7. So this is the answer. This is the simplified form. Okay, now let's go back and next find the restricted values. So like I mentioned to you guys, use original denominator, okay? Use original denominator. So you're going to take your original denominator and you're going to make it equal 0. So you're finding the values for which that expression doesn't make sense. That's what we're doing here. So we have x squared minus 49, and we're solving this equation. Now, this is easy already because you factor the denominator already, and this is the same as x minus 7 times x plus 7. So here you can use that zero product rule, which means take each factor and make it equal 0. So we're solving two equations. We end up with x equal 7 and x equal negative 7. So we have two restricted values. Okay, so let's do a little more. Let's see. So you have to simplify x squared minus 1 over 2x squared minus x minus 3. So let's do it again. So factor numerator. So we have x squared minus 1, which you can rewrite as x squared minus 1 to a second power. So you can apply that formula a minus b squared, which is the same as a minus b times a plus b. So in our case, we have x minus 1 times x plus 1. So let's save that. Next, factor the denominator. So denominator is quadratic equation, 2x squared minus x minus 3. You have to use AC method. A is equal 2, B is equal negative 1, C is equal negative 3. So step number 1, multiply A times C. We're getting 2 times negative 3, which is negative 6. Step 2, find two integers which by multiplication gives you AC, which is negative 6. And the same two integers by addition give you B, which is negative 1. So what's going to work? Negative 3, positive 2. Negative 3 and positive 2. Now, this is the case where you guys have to be careful when you're factoring because A is not equal to 1. Okay, so here you have to be careful. So you're going to create two factors, ax plus first integer times ax plus second integer and factor GCF from each parenthesis. and ignore it. That's how I teach you. So don't forget, okay? So we're having 2x minus 3 times 2x plus 2. So the first factor is 2x minus 3. Here there is no GCF. So we're going to keep it the way it is. The second factor is 2x plus 2. Here you have GCF. GCF, it's 2. So factor out GCF. That will give you x plus 1. And you're going to ignore that GCF. So next, you're going to rewrite using those two factors. So denominator, which is 2x squared minus x minus 3, is the same as 2x minus 3 times x plus 1. Okay. And next, what we're doing with that, we're going back to original expression, and we're rewriting this expression using our factors. So we simplify numerator. We got that x minus 1 times x plus 1. Next, we just factor the denominator, and we got 2x minus 3 times x plus 1. And just simplify. Cancel the repeating parenthesis. And we got x minus 1 over 2x minus 3, and this is our final solution. So I'm going to skip it for now, finding restricted values. How you're going to do it? You're going to take your original denominator, which is the same as 2x minus 3 times x plus 1, make that equal 0, and solve two equations. Okay. Oh, let's just do it. So to find restricted values, you take original denominator. Again, here, use factored form. And make it equal 0. So our original denominator, which was 2x squared minus x minus 3, when we factor, we end up with 2x minus 3 times x plus 1, make it equal 0. Solve two equations, and you will end up with x equal 3 over 2 and x equal negative 1. That's the restricted values. Okay, couple more examples. That's the last one. Simplifying a ratio of negative 1. So let me show you example. Let's say 5 divided by negative 5. We know this is equal to negative 1. Or negative 2 divided by 2. We know this is negative 1. But what happens when you have something like this? X plus 7 divided by negative x minus 7. So it looks like those expressions, numerator and denominator, they're the same, but they have opposite signs. So how are you going to know how to simplify that? This part, where you see negatives, factor negative 1. And when you factor negative 1, you change original sign to opposite, so that negative x will become positive x. That negative 7 will become positive 7. So now look what happened. Now you're ready to simplify this rational expression because you have x plus 7 on the top and x plus 7 on the bottom. So when you cancel expression in your numerator, if there's nothing what you see, that means there's 1 over there. On the bottom, you have -1. So that will give you just -1. So we're going to do a couple examples when you have to simplify rational expression by factoring -1. Okay, so this is the last example. Simplify rational expressions. And in here, your note will be by factoring -1. So let me show you. Let's do two examples. A, you have 2t minus 12 divided by 6 minus t. So to simplify rational expression, by now you guys know that you need to factor numerator, okay? So we're going to factor the numerator. This is easy to factor. You just have to factor the GCF, which is 2, and you're getting t minus 6. And I'm going to rewrite the denominator. I'm just going to switch the order because in the parenthesis, the first expression, it's t. So I will put -t first and plus 6. So this is exactly the same expression. So now I can't cancel them because on the top I have t, on the bottom I have -t. In parentheses, in numerator, you have -6. On the bottom, you have +6. So your expression have opposite signs. So how are we going to do it? Copy your numerator. And from denominator, here, factor out -1. So when I factor -1, each original expression become the opposite. So I have -t, I had -t, now I will have t. I had +6, so now I will have -6. Now you're ready to cancel. You have the same expression in the parentheses. So you will end up with 2 divided by -1, which is -2. That's the answer. And let's do B. One more. You have b minus a divided by a squared minus b squared. So what I'm going to do with numerator, since denominator has first expression a, so I'm going to rewrite it. I'm going to put my a and operation, which is in front of it, first, and the second expression will be b. Since in front of b you don't see any sign, that means b is positive, so you're putting plus b. So we just rearrange the order. Now, a squared minus b squared, factor using the formula. So very important formula, a squared minus b squared. This is difference of squares. This is the same as a minus b times a plus b. So a squared minus b squared is just a minus b times a plus b. So don't forget to simplify rational expression. You need to have a product, okay, which means multiplication in numerator and multiplication in denominator. Okay, now there's nothing what I can cancel, okay? It will be nice if you will have in numerator a minus b, okay? So to be able to get that a minus b, we're going to factor -1. So I'm factoring -1. So negative a will become positive a. Positive b will become negative b. And just copy your denominator. A minus b times a plus b. Now I'm ready to reduce this rational expression. I'm ready to simplify because I have multiplication in numerator and multiplication in denominator. So that's the only time when you can cancel expression. a minus b, it's repeating. Okay, so we're canceling a minus b, and we end up with negative 1 over a plus b. And that's our solution. Okay, that's it. This is section 15.1. Stop recording.